Hi there, my name is Tawfiq Omar Uthman, math teacher. For our lesson, we are talking about chapter 4, lesson 1, first derivative test, part B, local maximum and local minimum. Please do not forget that there is a link for the exercise of this lesson below at the description, and download it for yourself and use it carefully and correctly. And do not forget to subscribe the page too, and push the like button and write your comment if you have any, and if you have any question. Thanks for that. Let us start our lesson. At the lesson before, we talked about the critical value, how we can find the critical value and what is the critical value. We said that the critical value is the value of x in which the value of f prime of x is equal 0 or it is undefined. And now this kind of point or this kind of value is converting. Critical value a, x equal a, is converted to the local maximum if f of a is bigger than f of x for every value of x in neighborhood of a. And f of a is called local maximum, and fa is a maximum value. Local maximum change the sign of the derivative from positive to the negative, from left to the right. If this one is a critical point and at the left the sign of the f prime of x is positive, that means when the function is increasing, and at the right side the sign of the derivative is negative, that means when x is when fx is decreasing, this point is called a local maximum. This point is called a local maximum. And if you have a function like this, when the tangent line at this point is vertical parallel with the x-axis, the value of f prime of x at this point is equal to 0. And the sign of the derivative from left is positive and from right is negative. This point is called a local maximum. And if the graph is like this, because it has a trapped head, so the value of f prime at this point is undefined. When the sign of the f prime is positive at the left and negative at the right, so this point is called a local maximum. And the critical value x equal a is converted to the local minimum if fa is smaller than fx for every value of x in neighborhood of a, and f of a is local maximum and fa is a minimum value. The local minimum change the sign of the derivative from negative to the positive from left to the right. If this one is a critical point and at the left of this point is the sign of f prime x is negative, that means the function is decreasing, and at the right side the sign of the f prime is positive, that means the function is increasing. This point is a local minimum. And as we said, if the function graph is like this, and tangent line is parallel with the x-axis, this point is called a local minimum, and the value of f prime at this point is 0. And if the graph is like this, because it has a trapeze head, so the f prime is undefined. And now, as we can see, at the local maximum, the value of f prime is be 0 or undefined, or sometime is constant. Value of the derivative of equal is 0 if the graph of the function is like this. If the graph of the function is like this, at the local maximum and the local minimum, the value of f prime is 0 because the tangent line is parallel with the x-axis. But if the graph of the function is like this, it has a trapeze head, so the value of f prime is undefined. And if the graph of the function is like this, in this part of the function, in this part for the function, for example, in this graph from -1 to 0, the f prime is constant, and from -1 from 0 to the 1, it is constant too. So the value of f prime is 0 is if the graph is like this, and it is undefined is the graph of function is like this and it has a trapeze head. But if that's one like here, it is a constant value. Let us take example number 1. Find the value of the derivative of every local extrema. F of x is equal absolute value of x on the interval -1, 1. As you can see here, the function have a trapeze head, so the derivative of the function is undefined. That means f prime of x is undefined, and then it has a local minimum because here it is decreasing and the at the right is increasing, so it has a local minimum at the x equal to 0, and f prime of 0 is undefined. That means D is a correct answer. Example number 2. Find the value of the derivative of every local extrema fx is equal sine x on the interval 0 to pi. If we draw the graph of this function, or the graph of this function is given, so you can see this graph of the sine x, it has two local extrema. One of them at the pi over 2 and the second one is at 3 pi over 2. Because the tangent line are parallel with the x-axis, so the f prime is 0 at these 2 points. And now it has one local maxima at x equal pi over 2, and f prime of pi over 2 is 0, and it has a local minima at x equal pi over 3 pi over 2, where the f prime of 3 pi over 2 is equal to 0. That means A is a correct answer. Example number 4. The local extrema of the function f of x 9x squared minus 3 over x cubed are. And now to find the local extrema, first of all find the derivative of this function. The f prime of x is equal the denominator time the derivative of the numerator, which is 18x, minus the numerator times the derivative of denominator, which is equal 3x square over denominator square. Simplifying this one, f prime of x is equal minus 9x square minus 9 over x to the power 6, cancelling x square with the x to the power 6. So f prime of x is equal minus 9 x square minus 9 over x to the power 4. When we equaling this derivative by 0, the numerator be 0, because at the every rational function, if it was equaling to the 0, only the numerator is equal to 0. So x square minus 9 is equal to 0. That leads that x is plus or minus 3. And now drawing the table value x, the domain of this function is all real numbers except 0. So it's from minus infinity to the positive infinity, and we have two critical points, x equal minus 3 and x equal 3, because it is undefined at x equal to 0, so you must take 0. And now searching for the value of the f prime of x at minus 3 is 0, and at 3 is 0, and at 0 is undefined. For searching for the value, the sign of f prime of x, take a value from minus infinity to minus 3 and replace it at the derivative. You can see it is negative. That means the function is decreasing. By taking minus 4, for example, if we minus 4 replace it here, minus 4 square at the derivative, minus 4 square is 16, 16 minus 9 is 7, 7 times minus 9 is minus, so that means the sign of f prime is minus and the function is decreasing. When we taking a number between minus 3 and 0, let be minus 1, when we are replacing at f prime of x, it become minus 1 square is 1, 1 minus 9 is minus 8, a minus 8 times minus 9 is plus, that means it is here is a plus. So it is increasing at the interval minus 3, 0, and here is increasing and here is decreasing. That means the point minus 3 minus 2 is a local minimum and 3 2 is a local maximum, and it has a local minimum at x equal minus 3, and it is minus 3 minus 2, and f prime is minus 3, and f prime of minus 3 is 0. It has local maximum at x equal to 3, f prime of 3 is 0. So this one is a minimum and this one is a maximum. That means A is a correct answer. Example number 5. Find the local extrema of the function f of x is equal 1 over 2x cubed minus 3 over 4x squared minus 3x in the interval minus 2, 3. If the graph of the function is given, so you can see at the graph of this function there is two local extrema. One of them is maximum and the other one is minimum. And now if we draw the two vertical vectors from these 2 points over the x-axis, you can see x is minus 1 and here x is 2. That means it is increasing from minus 2 to minus 1 and decreasing from minus 1 to the 2, and from 2 to the 3 is increasing. That means increasing interval is -2, -1, 2, 3, and decreasing interval is -1, 2. And a local maximum has at x equal -1 and local minimum at x equal to 2. But if we have the equation of the function, first of all we must take a derivative. A derivative of fx equal 1 over 2x cubed minus 3 over 4x squared minus 3x is equal f prime of x is equal 3 over 2x squared minus 3 over 2 x minus 2 is equal to 0. And now making the derivative is equal to 0, so 3 over 2x squared minus 3 over 2x minus 3 is equal to 0 by multiplying with the inverse of the 3 over 2, which is 2 over 3, and it become x squared minus x minus 2 is equal to 0, and factoring it become x plus 1 x minus 2. From x plus 1 x equal minus 1, and from x minus 2 x is equal 2. They are a critical value. And now drawing the table value, x is from minus infinity, from minus 2 to the 3, and we have two critical points, -1 and 2. The value of f prime is at -1 is 0, at 2 is 0. And now to find the sign of f prime, take a number between -1 and -2, it become positive. And now it is positive, that means the function is increasing, and here it is negative, so the function is decreasing, and now here it is positive, that means the function is increasing too. That means it has a local maximum at -1, 7 over 4, and 2, it has a local minimum at 2, -5. Example number 6. Find the local extrema of the function f of x is equal 1 over 2x minus sine x in the interval 0 to pi. First of all, take a derivative of this function. F prime of x is equal 1 over 2 minus cosine x, because the derivative of 1 over 2x is 1 over 2, and the derivative of sine is cosine. Equal the derivative to the 0 and find the value of x. It become 1 over 2 minus cosine x is equal to 0, and cosine x is equal 1 over 2. Because the sign of the 1 over 2 is positive, that means the sign of cosine is positive. That means x is belong to the quarter number 1 and quarter number 4, and the starter value, because 1 over 2, the sign of x is 1 over 2, that means the sign of pi over 3 is 1 over 2. That means the standard sign is the standard angle is pi over 3. At the first quarter, x is equal pi over 3, and the fourth quarter, x is equal 2 pi minus pi over 3. 3 times 2 pi is 6. 6 minus 1 is 5 pi over 3. They are two critical points. And now, through the table value, x is equal from 0 to the 2 pi, and we have two critical pi value, pi over 3 and 5 pi over 3, and the value of f prime at these 2 points are 0. And taking f of x, and now take a value from any interval, but be careful, try to take pi over 2 or pi. As you can see, from pi over 3, 5 pi over 3, pi over 3, that means 16, and 5 pi over 3 is 300. That means here we have two pi and pi over 2. We can take pi or pi over 2. And now to find the value of y, or the value of fx, Replace pi over 3 at the function f of x is equal 1 over 2 x minus sine x. It become minus 0.34, and replace 5 pi over 3 at the function, and the value of y is become 3.48. And now if we take a pi over 2, f prime of pi over 2 is equal 1 over 2 minus cosine pi over 2. Cosine pi over 2 is 0. That means remain 1 over 2 minus 0 is 1 over 2. Because 1 over 2 is bigger than 0, that means the sign of the derivative at this interval from pi over 3 to the 5 pi over 3 is positive. Because in this interval it is positive, that means here it is negative and here is negative 2. That means the function is decreasing at the 0 pi over 3 union 5 pi over 3 to the 2 pi, and increasing from pi over 3 to the 5 pi over 3. And now the decreasing interval is from 0 to the pi over 3 union 5 pi over 3 over to the 2 pi, and increasing interval is from pi over 3 5 pi over 3, and it has a local minimum at x equal pi over 3 and local maximum at x equal 5 pi over 3. Example number 7. In which interval of x the function f of x is equal cosine x minus 1 over 2x has a local extrema in the interval 0 to pi. And now to find or to answer this example, only take the derivative of the function f of prime of x is equal minus sine x minus 1 over 2. And now to know which one is the value of x which the function has a local extrema, replace the value of x at this derivative. If it was equal to 0 or it is undefined, that means this function has a local extrema. And now to be sure, we must take f prime of x is equal minus sine x minus 1 over 2, and now equal to the 0, so minus sine x minus 1 over 2 is equal to 0, so sine x is equal minus 1 over 2. Because the sign is negative, so the x is belong to the quarter number 3 and quarter number 4, and the standard value of x is pi over 6, that means 30. And now at the third quarter, x is equal pi over 6. 6 times pi is 6 pi plus pi is 7 pi. That means it is 7 pi over 6. At the quarter number 4, x is equal 2 pi minus pi over 6. 6 times 2 pi is 12 pi minus pi is 11 pi over 6. They are a critical value. And now draw the table value. X is equal from 0 to the 2 pi, and we have two critical points, 7 pi over 6 and 11 pi over 6, and the value of f prime is 0 at these 2 points. And now f of x, replace 7 pi over 6 at the f of x and find the value of f of x, and 11 pi over 6 at the function and find the value f of x, it's minus 2. And now to finding the sign of the derivative, take pi over 2 at one interval. 7 times 13 is 210. That means pi is here and 2 pi is here. So I will take pi here and replacing at the f prime of x. It become f prime of pi is equal minus sine pi minus 1 over 2. Sine pi is 0. That means remain minus 1 over 2. Minus 1 over 2 is less than 0. That means the sign of derivative is negative and the function is decreasing. Because it is here negative, so it is positive here and negative here. That means decreasing, increasing, decreasing. And now decreasing interval is from 0 to the 7 pi over 6 and from united with the 11 pi over 6 to the 2 pi. And now increasing interval is 7 pi over 6 to the 11 pi to the over 6. And it has a local maximum at x equal 11 pi over 6 and local minimum at x equals 7 pi over 6. As you can see, B is right and C is right. That means B and C are right. That means the correct answer is D. Question number or example number 8. Find the local extrema of the function f of x is equal cube root of x squared minus 4. First of all, take the derivative using this rule. The derivative of the nth cube square x to the power m is m over n square root of n radical n and x to the power n minus 1. It becomes f prime of x is equal to over 3 cube root over x, cube root over x. And now, because the numerator of this function is constant, so it's not equal to 0. And now we are searching for the value of x which make the f prime of x is undefined. To do that, take the denominator equal to the 0. That means cube root of x is equal to 0. That means x is equal to 0. Because the domain of the function is all real number, so x is belong to the domain, so x is equal to 0 is a critical value. And now f of 0 is cube root of 0 square minus 4. It is f of 0 is minus 4, so 0 minus 4 is a local extrema. To find if it was a maximum or minimum, so we must draw the table of value. X is from minus infinity to the positive infinity and 0 is a critical value. F prime of x is 0 at 0 of f prime of x is undefined, and if we take minus it become minus, and if we take a positive number it become positive. That means the function is decreasing, after that increasing. That means it has a minimum, local minimum. 0 minus 4 is a local minimum point. That means C is a correct answer. Question number 9. Let f of x is equal x squared x plus 1. Which of the following is false? First of all, let us take a derivative. The derivative of this function is become denominator x plus 1 times the derivative of the numerator, which is x squared, it is become 2x, minus the numerator, which is x squared, times the derivative of denominator, which is 1. That means denominator is equal square. That means x plus 1 is square. Simplifying, f prime of x is equal x squared plus 2x over x plus 1 square. Because the denominator is square, it is every time for every value of x it is positive. And now make it equal to 0 because it is a fraction, or it is a rational number, so the numerator is become equal to 0. x squared plus 2x is equal to 0, and factoring x times x plus 2 is equal to 0, x equal to 0 or x equal to the minus 2 are two critical value. And now draw the table value. X is from minus infinity to the positive infinity, and minus 1 is undefined function. That means the domain of this function is all real number except minus 1. And now we have two critical points, minus 2 and 0, and the value of f prime of x here is 0, here is 0, and here is undefined. So we have here positive, because if we take a minus 3 square is 9, 2 times minus 3 is minus 6, 9 minus 6 is 3, that means it is positive. That means function is increasing here, and here is decreasing, and here is decreasing, and here is increasing too. That means the increasing interval is from minus infinity to the minus 2 union from 0 to the positive infinity, which means the first one is right. This one is right. And now the decreasing interval is from minus 2 to the minus 1, from minus 1 to the 0. That means the second one, B, is right too. And if x is equal to the minus 1 is a vertical asymptote, it is right, because to find the vertical asymptote, only take the denominator and make it to the 0. X plus 1 is equal to 0. That means it is undefined, and x is a vertical asymptote. And now the third one is 2, true. That means 0, 0 is a local maximum. As you can see here at the graph of the function, it is a minimum. So D is the false. That means D is a correct answer we choose. And now use the graph of the function f of x is equal absolute value of x plus 3. Which of the following is true? First of all, you can see the function is less than minus 3, or from minus infinity to the minus 3 it is decreasing, and from minus 3 to the positive infinity is increasing. That means the first one, if the first one is not true, this one is wrong, and interval, decreasing interval from minus infinity to the positive infinity is false. F prime of minus 3 is equal to 0. It's not true, because you have a trapped head. That means f prime of minus 3 is undefined. That means this one is false too. Remain fx has a local minimum. It is true, because it is changing the decreasing to the increasing. That means this point is a minimum value. That means D is a correct answer. Question number 11. In the graph of the function f of x is equal x minus 1 cube, which of the following is false? The first of all, we must take the derivative of the function f of prime x is equal 3x minus 1 square, and it is for every value of x it is positive, because every square number is positive, and positive time positive is positive. That means f prime of x is every time is positive. But you can see at the graph of the function is increasing at the domain of the function. That means for every value of x at the domain. And now f is increasing. F prime of 1 is equal 3, 1 minus 1, which is equal to 0. And because it is increasing, that means both sides is the same thing. The 1, 0 is only a critical value. As we doing, looking at the choosings, you can see it says f of x increasing in the domain. It is true. F prime of x every time is bigger than 0. It is true. F prime of 1 is equal to 0. It is true. That means it has a local maximum. It's not true because we have only a critical value. That means the right answer is D. Here we came to the end of the lesson. Thank you for listening, and please do not forget there's a link for the exercise of this lesson at the description below, and do not forget to write your comment and subscribe the page and push the like button. Thank you again for watching.